Hello everyone. You know that we have already learned limits and continuity. And now in this session, we are going to focus on how to compute limits. So for that, we need to know some laws or properties of limits. So let me write the properties at first. The first one is the sum law or sum property, then difference property, product property or product law, then we can say constant multiple law, then we have quotient law, we have also root law, and we have power law. So what is sum law? Sum law says that limit of f of x plus g of x will be equal to limit of f of x plus limit of g of x. That means we can see that limit is being distributed with these functions. So it is said that the limit of a sum is the sum of the limits. Similarly, we can think about the difference rule. So at first, let us have one example of sum property. Suppose we have a limit x tends to 2, x squared plus e power x. So this is considered as f of x and this is g of x. So what we can do, we can write this one as limit of x squared plus limit of e power x. So now we have to input 2 where we have x, this is the position x, and here we have x. So we are plugging 2. So 2 squared plus e power 2, we have 4 plus e squared. So this is a finite value. That means limit exists. That means we are computing directly using the limit laws. So here we have used the property sum property. Similarly, let's have a look on the difference rule. Limit x tends to a, f of x minus g of x. So what we can write, limit x tends to a, f of x negative limit x tends to a, g of x. That means just like the sum law, we can say that the limit of a difference is the difference of the limits. So let us have one example for this property. Suppose we have limit x is approaching to 0 sine x negative e power 2x. So what we can do here, limit x tends to 0. So you can see that we have a negative sign. So that means if we consider this one as f of x and this is as g of x, limit of f of x minus g of x, so we can write limit of f of x minus limit of g of x. So where we have x, we need to just plug 0. So sine 0 negative e power 2 times 0. So that means 0 negative e power 0. So 0 minus 1, you know that e power 0 is 1. So we have minus 1. This is also a finite value. That means limit exists. So besides sum and difference properties, we need to know what is product law. So limit x tends to a, This time we have f of x times g of x. So if we have this product f of x times g of x, then we can write this one as limit of f of x times limit of g of x. That means the limit of a product is the product of the limits. So let's have another example. This time the example is for the product law. So suppose we have to compute limit x is approaching to 0 sine x plus x squared plus 1 times e power x. So we can consider this one as f of x and this is as g of x, and there is a product here, f of x times g of x. So what we can do, limit of f of x times limit of g of x. So we have applied the product rule. We can also see that here we have positive. So that means we can also apply the sum law here. If we consider f of x, this is g of x, let's say this is h of x. So what we can write, limit x tends to 0 sine x plus limit x tends to 0 x squared plus limit x tends to 0 1 times we have limit x tends to 0 e power x. So now this is the time to input 0 where we have x. So sine 0 plus 0 squared, limit of a constant, always remember that limit of a constant is a constant. Limit x tends to a of constant is equal to the same constant. So it will be 1 times e power x, that means e power 0. So we have 0 here, 0. So finally we have 1 and e power 0 is also 1. So the result is 1. That means we can say that limit exists because this is a finite value. So limit exists. So we have seen that here the product property has been applied. Besides this, since we have the sum, so we can also apply sum property. So now let's have a look on another property that is known as constant multiple law. So it says that if we have limit of c times f of x, where c is the constant, so this property says that we can bring this constant before the limit. So for example, we can think about one example here. Let's say we have limit x tends to 2 5 x squared plus 1. So here you can see that 5 is a constant and this is f of x, c times f of x. So what we can do, we can bring this constant before the limit. So limit x tends to 2 x squared plus 1. So we have 5 and this limit. So now we can see that we have also a sum. So we can apply the sum law to compute the limit. So limit x tends to 2 x squared plus limit x tends to 2 of 1. So finally we can write 5 times x squared, that means 2 squared. Limit of a constant is a constant. So we have 5 times 4 plus 1, that is also 5. So we are getting 25. This is also a finite value. So we can say that limit exists. So we can understand that every time we need to know the properties, and by using the properties we can easily compute the limits. But once you have a practice over all these theorems or properties or laws, then you can directly solve the problems. That means here I have solved step by step, but you don't need to apply all these steps. You can directly find the result by writing this. Okay, so the reason behind showing all these properties is that we need to know how limits are applied, how the properties can be applied to compute any limits of a function. So that's the reason why I am writing the properties here. So now let's have a look on the quotient law. So here it says that limit of f of x divided by g of x. So if we have this case, then limit will exist if this one is a finite value. That means the existence criteria says that we must have a defined value here, but at the same time have a look, limit x tends to a f of x by the g of x. So what we can do here, limit of f of x divided by limit of g of x, f of x divided by g of x. Now here limit of f of x divided by limit of g of x. So this limit will only exist if the denominator that we have here, limit x tends to a g of x, becomes non-zero. If this is 0, then the limit will not exist. So limit will exist if the denominator is not 0. So let's have a look on one example of the quotient law. So suppose we have limit x tends to -2 x cubed plus 2x squared -1 5 -3x. So if we want to compute this limit, at first what we can do, we can apply the quotient law. So it means limit will be in the denominator and also in numerator. So limit x tends to -2, limit x tends to -2. And we have the function above, that is x cubed plus 2x squared -1. We have another function in denominator, 5 - 3x. So this time you can see that we have plus minus minus. That means we can apply the sum property, also the difference property that we have seen for the previous examples. Okay, so sum law and difference law can also be applied here, but if we want, we can also solve this one directly. So this time I will solve directly so that you can also understand how we can manipulate the limiting problems directly. So here, at first, we have to check whether the denominator becomes 0 or not. So if we input -2 here, so it becomes 5 -3 -2. That means 5 -3 times 2, that is 6. So negative negative positive, we are getting 11. So the denominator is not 0. That means the limit is going to be a finite value. So limit will exist. So this says that limit will exist. Limit will not exist if the denominator becomes 0. So for this case, we are going to have a finite value. Now, I am going to write directly here. If we want, we can also write in this way: limit x tends to -2 of x cubed plus limit x tends to -2 of 2x squared minus limit x tends to -2 of 1. So if we want, we can also write by this way, but this time I want to solve this one directly. Okay, so sometimes if you want, you can also skip these steps. Okay, but we have to know how we can apply the properties. So now -2 will be plugged where we have x. So x cubed, that is -2 cubed, plus 2 times -2 squared minus 1. So where we have x, we are just plugging -2. That is the direct format. Similarly, where we have x in the denominator, we are plugging -2. So here in the upper part, we have -8. If we compute this one, 4 times 2, that is 8, -1. And in denominator, we have already seen that it will be 11. So finally, we are going to have -1 divided by 11. That is a finite value. So limit exists. Okay. So we have seen that how the quotient property is being applied. Limit of f of x divided by g of x can be written as limit of f of x divided by limit of g of x. So after sum, difference, product, constant multiple law, and quotient law, we also have to know another two laws. So one is power law, another one is root law. So root law says that limit x tends to a nth root of f of x. So if we want to compute this limit where n is a positive integer, n should also be an even number. So if we have to compute this limit, then what we can do? We can write the total nth root at first, and then limit can be written inside. So limit of f of x when x is approaching to a. So by this way, we can easily solve the problem. So if we have a look on one example, suppose we have limit x tends to 3, x squared -4. So you can understand that from the concept of function, this inside quantity should be greater than or equal to 0. Otherwise, we will have undefined part. So what we can do, we can understand that this square root can be written at first by using the root law, and limit can be written inside. So we have limit of x squared -4. So we have square root. Now we can apply the sum or difference property if we want. Actually, negative is also one kind of positive, because if we think about x squared -4, it is also x squared plus -4. So we can apply sum property or difference property. Those two are same actually. So if we want, we can also solve directly. So this time I am going to solve directly. So where we have x, I am plugging 3. 3 squared -4. So we have 9 -4. That is, it will be square root of 5. So square root of 5 is a finite number. That means limit exists. If we have a finite value finally, then we can say that limit exists. So this is about square root. Suppose instead of this problem, we have fourth root of this function. So that means all the things will be same. And this time the result will be fourth root of 5. This is also a finite value. So limit exists. That means limit x tends to a, nth root of f of x can be written as limit x tends to a, f of x, nth root outside. So limit will be given in the inside part. So remember that this n should be an integer, positive integer, and n should be even. Now let's have a look on power law. So what is power law? Suppose we have limit x tends to a, f of x power n. So f of x with power n. So what we can write? We can write just like the root law. We can write here limit x tends to a, f of x total power n, where n is a positive integer. So you can see that there is a similarity between root law and power law. So if we take one example, suppose we want to compute the limit of x squared plus 1 power 3 when x is approaching to 0. So you can understand that if we consider this one as f of x is x squared plus 1, and we have n that is 3. So by using power law, what we can write? We can write limit of f of x total power 3. So now it is easy to compute. If we input 0 where we have x, so we have 0 squared plus 1 power 3. That means if we write in a nice way, then it will be this one. So we have 1 cubed, that is actually 1. This is a finite value. That means limit exists. So if we want, we can also solve this problem in another way. Suppose this is method 1, where we have applied the power law. That means power law says that if we have f of x power n and there is a limit, so limit of f of x power n, so total power n. But if we want, we can also solve this problem in another way. Let's say this is method 2. So limit of the same function x squared plus 1 power 3. So this time we can apply this formula. We know that a plus b power 3, that is a cubed plus 3a squared b plus 3ab squared plus b cubed. So it will be x power 6 plus 3 a squared, that means x squared times another x squared. So it will be x power 4. That means 3a squared b, 3x squared power 2 times b is 1. So actually we have 3x power 4 plus 3ab squared. So 3x squared times 1, that is actually we have 3x squared plus 1 cubed. That means we have 1. Now we can apply the sum property because we have summation, summation, summation. But if we want, we can also write directly. So we need to input 0 where we have x. So 0 power 6, that is actually 0, plus 3, 0 power 4. Let me write power 6 here so that you can understand where we are plugging the value of x. So 3 times 0 is squared plus 1. So finally you can see that it is 0, 0, 0 plus 1. So 1. That means it doesn't matter whether we apply this method or this method. We are going to have the same result. But we can understand that by using the power law, we can solve the problem quickly. Okay. So that is the advantage of using power law. So the properties or the laws that I have written here, these are very important while computing limits. So we have to recall these properties always so that we can easily apply whenever we have complicated examples. So besides this, I have already mentioned you that, let's say, limit of a constant, that will be a constant. So you need to also remember this one. Now let's come to the main part of this session. We know that in week 1, we have some techniques to compute limits, that is algebraic manipulation technique. Another one is chains of variable. We have also squeeze theorem, and we have a special rule that is known as L'Hopital rule. So you will find the discussion of L'Hopital rule in this lecture. So you can see that here I have a lecture on indeterminate forms and L'Hopital's rule. So you can go through this one from here. So you can understand L'Hopital's rule from that lecture video. But in this session, we are going to discuss about algebraic manipulation method and chains of variable. In our next sessions, we will try to talk about squeeze theorem. So let's start with algebraic manipulation method. So algebraic manipulation means we are dealing with algebraic techniques. So let's say the first technique that we can use to compute limits. Suppose we have to compute limit x tends to 3, x squared negative 9 divided by x minus 3. So this technique says that we have to reduce the function as much as we can. At first, let's have a look why we are doing this type of reduction of these functions. So try to understand, if we input 3 where we have x, so the upper part becomes 9 minus 9 divided by 3 minus 3. That means we have 0 divided by 0. So actually 0 divided by 0 is an indeterminate form. We can apply L'Hopital rule to solve that. But suppose it is mentioned that you have to solve this problem without using L'Hopital's rule. So at that time, algebraic manipulation method is the only way to solve this one. So what we can do, we have to reduce this function as much as we can. Okay, so we have to bring a simplified version of this function so that we can easily compute the limit. Actually, we have 0 by 0, but this limit may be a finite value. Okay, so how we can solve this one? Let's see. So the first technique says that we have to simplify the given function as much as we can. So let's see. Limit x tends to 3, x squared minus 9 divided by x minus 3. So what we can do, x squared negative 3 squared divided by x minus 3. We are trying to reduce the given function. So we need a simplified form. So it is a squared negative b squared, that is a plus b into a minus b. So we have finally these two similar terms. That means we can easily cancel these two. So we have limit x is approaching to 3, x plus 3. Now what we can say, we can input 3 where we have x. So you can see that at first we have x squared minus 9 divided by x minus 3, but after doing some algebraic calculations, we have found a simplified form of the given function. So that is the target. So to compute any complicated limits, at first, our first target should be to reduce or simplify the given function as much as we can. So where we have x, just input 3. So the result is 3 plus 3, that means 6. So 6 is a finite value, that means limit of the given function exists. So you can understand that by simplifying this function, we can avoid 0 by 0. The same problem can be solved by L'Hopital's rule. You can understand L'Hopital's rule from the video that I have given here, indeterminate forms and L'Hopital's rule. So this is, let's say, technique 1. That means we have to simplify the given function as much as we can to compute the given limit. Let's think about another technique. Suppose we have technique 2. So sometimes we may have a square root form. Let's say square root of something plus a. So if a function involves this type of square root terms plus a means anything can be here. So to compute the limit, we need to simplify as much as we can. But to have the simplifications, we need to multiply the opposite similar term. That means same thing is here, but opposite term is negative. So instead of plus, we have to use minus. So we need to multiply this term in numerator and in denominator. So you will understand if we take one example. Suppose we have limit x tends to 1, x minus 1 divided by square root of x negative 1. So at first, what we can say, we can input 1 where we have x. So 1 minus 1 is 0. Here, the square root of 1, that is 1. So 1 minus 1, again 0. So the same problem can be solved by L'Hopital's rule because we have 0 by 0. But suppose it is mentioned that don't use L'Hopital rule. Use algebraic manipulation technique to solve this. So how can we solve? It is showing at first 0 by 0, but there may be a finite value. So we need to find that. So for that, we have to multiply the opposite similar term. You can see that here we have square root of x minus 1. So its opposite term should be square root of x plus 1. Where we have minus, we are using plus. So this term should be multiplied both in numerator and in denominator. So that means we have x minus 1 and square root of x minus 1 here. So we are multiplying square root of x plus 1 in both numerator and in denominator. Now we can easily reduce this function. So if we take a look, that means this one and this one are similar, we can easily cancel. So this equation and this one are same. So multiplying this quantity in numerator and denominator doesn't have any effect. So now we can see that in the denominator we have a plus b, a minus b. That means we can write the denominator as a squared negative b squared, and in upper part we have the same thing as it is before. Limit x is approaching to 1. So limit x approaching to 1, we have now x, because square root of x is squared, that is x only, x minus 1, x minus 1, square root of x plus 1. So you can see that now after multiplying this opposite similar quantity, we have obtained a reduced term root over x plus 1, and this similar term can be cancelled. So we can see limit x tends to 1 is square root of x plus 1. So this is the simplified form of this given function. Now we can input the value of x where we have x. So x is approaching to 1, that means square root of 1 plus 1. That means we have 1 plus 1, that is 2. So 2 is a finite value. So limit of this function actually a finite value. That means limit exists. But at the very first time, we have seen that it is showing 0 over 0. But actually, the limit will be 2. So remember, in technique 1, what we have learned, we have to simplify as much as we can. Same thing we have done here. We are simplifying as much as we can. And this is the simplified form. But at the same time, we have understood another thing. That is, if we have square root plus something, we are multiplying opposite similar term both in numerator and in denominator. So let's have another example. Suppose we have to compute the limit of square root of x squared plus 9 negative 3 divided by x squared. So at first, we can input 0 where we have x. So it is becoming 9 negative 3. That means actually we have 3 negative 3. So it is 0. And in denominator, we have also 0. So we can see that it is giving us 0 over 0. That means it is an indeterminate form. We can apply L'Hopital's rule to solve this. But here we are not going with L'Hopital's rule. We have to solve this one with algebraic manipulation technique. So how we can reduce or simplify this one? We have square root negative 3, square root of something negative 3. So this can be solved if we use opposite similar quantity. So the opposite similar quantity of this one is x squared plus 9 square root and 3. Here we have negative, we have to use positive. So this quantity should be multiplied both in numerator and in denominator. Okay. Let's see how we can solve this one. We have square root of x squared plus 9 negative 3. In denominator, we have x squared. Now we are multiplying the opposite similar quantity. It is x squared plus 9 square root plus 3. And same thing will be in denominator. So if we take a look, these two parts are similar. So we have actually the same thing as it is before. But we are multiplying this quantity so that we can easily solve the problem. So limit x tends to 0. In denominator, we have x squared, square root of x squared plus 9 plus 3. And in upper part, if we consider this is a and this is b, a plus b, a minus b. So that means a squared negative b squared formula can be applied. So a squared negative b squared. So we can write now limit x tends to 0. The reduced part will be only x squared plus 9, negative 3 squared is 9. And in denominator, we have x squared, square root of x squared plus 9 plus 3. So finally, we have limit x tends to 0, x squared divided by x squared, square root of x squared plus 9 plus 3. So now we can see that we can cancel x squared and x squared. So we have 1 in the numerator. So 1 divided by square root of x squared plus 9 square root plus 3. So this is the simplified form. Okay. Now we can input the value of x. X is 0. So limit x tends to 0, 1 over square root of x squared plus 9 plus 3. I am writing again here. So we need to input 0 here. That means 1 over square root of 0 squared plus 9 plus 3. 0 squared is actually 0. So we have square root of 9 plus 3. That means we have 3 plus 3, 1 over 6. So it means it is a finite value. That means limit of the given function exists. Okay. So previously it was showing us 0 over 0, but actually after multiplying a specific quantity both in numerator and denominator, we have 1 over 6, that is a finite value. So we have learned technique 1 and technique 2. Let's have a look on technique 3. Technique 3 is also same as this one. Here we have multiplied the opposite similar term if we have a square root plus something. So let me write technique 3. So sometimes we may have 1 negative cosine theta or 1 negative cosine x in numerator or in denominator. That means in any limit, if this quantity is involved, then we have to multiply opposite similar quantity. If we have 1 negative cosine theta or 1 negative cosine x, we will multiply 1 positive cosine x or 1 positive cosine theta. Okay, this should be multiplied both in numerator and in denominator. So let's have a look on one example. Suppose we have to compute limit x tends to 0, x squared divided by 1 negative cosine x. At first, if we input 0 above, so 0 squared, that means 0, cosine 0, 1, so 1 negative 1, that is also 0. That means it is giving us 0 by 0 form. So this is an indeterminate form, but we can't apply L'Hopital rule here. It is suppose mentioned that you have to apply algebraic manipulation technique. So we are not going to apply L'Hopital's rule. We are going to apply algebraic manipulation technique. So we can see that we have 1 negative cosine x. So to simplify this function, we have to simplify as much as we can. But to simplify, what we have to do? We have to multiply opposite similar quantity. So 1 negative cosine x, its similar quantity will be 1 plus cosine x. So here we have minus, here we have plus. So we have the opposite similar quantity. So just to balance with the previous part, we are multiplying the same thing in the numerator. Now this and this can be cancelled. We have the same thing as we have this one. So after multiplication of 1 plus cosine x in both numerator and denominator, what we can do? We can simplify. Here we have a plus b, a minus b. That means we can apply a squared negative b squared formula. So we have x squared above times 1 plus cosine x. So limit x tends to 0, 1 negative cosine squared x, x squared 1 plus cosine x. Now what we can write? Limit x tends to 0, 1 negative cosine squared x can be written as sine squared of x, because we know that there is an identity sine squared x plus cosine squared x equals 1. So sine squared x will be 1 negative cosine squared x. So this is a formula. Now we can see we have x squared in the numerator, also 1 plus cosine x in that part. So let me write this one here again. So this is the simplified form that we have here, x squared times 1 plus cosine x divided by sine squared x. But if we have a look here, if we input 0, still it is giving us 0 times something divided by 0. It is 0 over 0 again. So we have to simplify again because we can't remove 0 by 0. That means simplification will be continued. That means after multiplication of 1 plus cosine x, both in numerator and denominator, still we have 0 by 0. So we have to simplify this one. We have to know how we can simplify. So we are lucky that we have the property product rule, that is limit x tends to a f of x times g of x. We have seen that the limit of a product is the product of the limit. Okay, we have seen this one earlier whenever we have started the session. So limit x tends to 0. We can write this one as x squared divided by sine squared x times 1 plus cosine x. So that means this is f of x function and this is g of x function. So what we can do, limit x tends to 0, x squared divided by sine squared x times limit x tends to 0, 1 plus cosine x. So you can see that the product rule or product law has been applied here. Now we also know another property. Let me write this one at first, then I will write the property. So limit x tends to 0. If we rearrange this one, it will be x divided by sine x squared. Okay, same thing, times limit x tends to 0, 1 plus cosine x. So we know a power rule, that is if we have limit x tends to a f of x power n, then what we can do, limit will be here and total power n. Okay, so here we can see we can also apply power rule. So limit x tends to 0, x divided by sine of x, total power 2, limit x tends to 0, 1 plus cosine of x. Now you can understand that we have applied this power rule. So at the same time, we need to remember a formula, that is limit x tends to 0, sine x divided by x, it will be 1. Similarly, we have to know limit x tends to 0, x divided by sine of x equals 1. We also know that limit x tends to 0, tangent of x divided by x equals 1. Similarly, limit x tends to 0, x divided by tangent of x equals 1. So these formulas are useful. So you can see that this one is going with this formula. So limit x tends to 0, x divided by sine x is actually 1. So 1 is squared times the next limit is very easy to compute. Here we have x. So just we can input 0 where we have x. So we can see that 1 plus cosine x, that means 1 plus cosine 0. I have used a different color so that you can understand where we are plugging 0. We are plugging 0 where we have x. So 1 times 1 plus cosine 0, its value will be 1. So 1 times 2, that is equal to 2. So it is a finite value. That means limit exists. So I have mentioned this one as technique 3. If we have one negative cosine x or cosine theta, we have to multiply this quantity both in numerator and denominator. Then we will have the simplified version of the given problem. So this is how we can apply algebraic manipulation technique. Let's have a look on another technique. Let me write this one as technique 4. Okay. So sometimes we may have x tends to infinity, plus infinity, or x tends to minus infinity. Okay. That means the limit has the form x tends to a, where a is plus infinity or minus infinity. So if we have this case with f of x divided by g of x. So if we have this type of format, suppose this is a polynomial function, this is another polynomial function. Polynomial means we have x squared plus 5x plus 6, let's say, in the upper part, and in denominator we have x cubed plus 3, like that. Okay, so these are polynomial functions. So what we can do to compute this limit, we have to divide each term by the highest power of x that occurs in the denominator. So you will understand if we have a look on one example. But at first, let me write what we have to do to solve this one. We have to divide each term, that means each upper part and lower part. Divide each term of numerator and denominator by the highest power of x that occurs in the denominator. So suppose f of x has 3 terms. So all these 3 terms should be divided by the highest power of x that occurs in denominator. So what do we mean by highest power? Suppose we have x squared plus 5x plus 6. So we can understand that here x has power 2, x has power 1. If we consider this one as x power 0, we know that x power 0 is 1. So out of these 3 terms, x power 0, x power 1, x power 2, which x has the highest power? Obviously, this one, highest power is 2. Here power is 1 and power is 0. So highest power is 2. That means what we have to do? We have to divide all this quantity with this highest power of x. So at first, have a look on the keywords. That is, we have to divide each terms of numerator and denominator by the highest power of x that occurs in the denominator. Always focus on denominator, not in numerator. So you will understand if we take one example. Suppose we have to compute limit x tends to infinity. Infinity means plus infinity. So for x squared negative x divided by 2x cubed negative 5. So we can understand that we have f of x here and g of x. Both these are polynomial. So we have to focus on the denominator. Since we have infinity, so this technique says that if we have plus infinity or minus infinity, what we have to do? We have to divide with the highest power of x that occurs in denominator. So in denominator, we have 2x cubed negative 5. So which one is the highest power of x? If we think about this way, 2x cubed negative 5, x power 0. X power 0 is 1. So this one and this one are same. So highest power is obviously here. So that means we have to divide by x cubed, both in numerator and in denominator. So let me think about this way. We have figured out that x cubed is the highest power of x in denominator. So what we can do? Limit x tends to infinity, 2x cubed negative 5 divided by x cubed. So at the same time, 4x squared negative x divided by x cubed. That means we have to divide both numerator and denominator with this highest power of x that occurs in denominator. So I hope it is easy to understand. Now, what we can do here, we have to simplify, because algebraic manipulation method says that we have to simplify as much as we can. So here it will be 2x cubed negative x cubed if we separate this one. Similarly, in upper part, we will have 4x squared divided by x cubed negative x divided by x cubed. So limit x tends to infinity. Actually, we have plus infinity here. Okay. So now let us simplify. Let's have a look on denominator at first. X cube and x cube will be cancelled. So we have 2 only, negative 5 over x cubed. In upper part, the reduced form will be 4 divided by x, negative x divided by x cubed. It will be 1 over x squared. So we have found the simplified form. Our target is fulfilled. Now we can input this one. So you can understand that why we have divided both f of x and g of x by x cubed. The reason is we know that anything divided by infinity, that will be 0. So our target is to form this type of terms. Okay, so already we have that figures. So limit x tends to plus infinity. If we input this one, where we have x, so you can look at the positions of x. Here we have x, x, and x. So 4 divided by infinity, negative 1 divided by infinity squared, that means it is actually infinity, 2 negative 5 over infinity cube. So you don't need to show this one, you can directly write the result here, but for better concept, I am writing by showing all these steps. So a divided by infinity, it is 0. So that means 4 divided by infinity, that is 0. 1 divided by infinity squared, that means it is infinity. So 1 divided by infinity, that will be also 0. In denominator, we have 2. Negative 5 divided by infinity cubed, that is infinity also. 5 divided by infinity, that is 0. So our target is to form this term. That's why we have divided by the highest power of x that occurs in the denominator. So always remember this one. Now you can see that it is actually 0 minus 0, that is 0. 2 minus 0, 2. So we have 0 divided by 2, that is 0. So it is a finite value. That means we have found a finite value. That means limit exists. Okay, so you can see by this technique that we have mentioned as technique 4, we can easily solve this problem. Let me solve another problem that is not directly as this one. Here we have applied x cubed in the division part because we have polynomial function. But suppose we have a logarithmic function, but we can still apply the same technique. That means suppose we have to compute limit x tends to plus infinity natural log of x plus 1 divided by x. So at first, if we have a look on x here we have infinity. So infinity plus infinity, that is infinity, and divided by infinity. So actually we have infinity divided by infinity. So that means it can't be solved directly. We have to take the help of one technique. So what we can do here, limit x tends to infinity. Don't focus on natural log. Suppose it is here as it is before. We have to focus on here. Which term is the highest power of x that occurs in denominator? Obviously, x in denominator, we have x. So this is also the highest term because we don't have any other term other than x. So what we have to do? We have to divide by x both in upper part and in lower part. So x divided by x plus 1 divided by x. So the thing is, we are dividing by x. Now we can easily compute limit x tends to plus infinity natural log. We can write here as x plus 1 divided by x to x divided by x plus 1 divided by x. And here it can be written as 1 because x and x are cancelled. So we have limit x tends to plus infinity natural log x by x, that is 1, plus 1 over x divided by 1. So actually we can simplify this one as natural log 1 plus 1 divided by x. No need to write 1 again in the denominator. We can skip that. Okay, now we can input infinity where we have x. This is the simplified form. So we are applying all these techniques so that we can simplify the given limit as much as we can. So now we are plugging infinity, let's say. So natural log 1 plus 1 divided by infinity. So 1 divided by infinity, that will be 0. So natural log of 1 plus 0, that means we have natural log of 1. So you know that log 1 is 0. So this is a finite value. That means limit exists. So limit of this function actually exists when x is approaching to plus infinity. So these are the techniques that we know as algebraic manipulation method. So now let's focus on chains of variable. So chains of variable is also algebraic manipulation technique, okay? But sometimes we have to change the variable. So there is no difference between chains of variable and algebraic manipulation method. Actually, these two can be merged, but chains of variable says that we have to change. Suppose for this example, here we have x should be changed to another variable to compute the limit, okay? That means our target is to make the simplified version of the given problem. So for that, sometimes we need to change the variable. So we are starting now chains of variable. Suppose we have a problem that is limit x tends to 0, sine 3x divided by x. So if we input 0 here, so sine 0, that means 0, and in denominator we have also 0. So that means it is giving us 0 by 0 form. That means it is an indeterminate form. So we can apply L'Hopital's rule to solve that. But suppose it is mentioned that don't use L'Hopital rule, use chains of variable or algebraic technique. So how can we solve this one? Let us recall a formula that we know. Limit x tends to 0, sine x divided by x equals 1. I have written these formulas previously. Okay, so this x doesn't matter. We may have another format, that is limit, say we have theta tends to 0, sine theta divided by theta equals 1. So same thing. The main format is you must have to be theta both here and here. At the same time, this one should also be theta. That means we have to focus on 3 parts. That means here, then sine of x, and then the denominator x. If these 3 things are same, then only we can write 1. So this is the formula. So here we can see that we have sine 3x, but here we have x, here we have x. So 3x and x, obviously these two are not same. So we have to make 3x here anyhow. So how we can do that? At the same time, we also have to make 3x here. So we need the help of chains of variable. So let's see. Limit x tends to 0, sine of 3x divided by x. So just to have 3x in the denominator, suppose I am writing 3x, but it is not balanced with the previous one. So just to balance, I am again multiplying 3 in the numerator. Now 3 and 3 can be cancelled. We have the same thing. So this is how we can adjust this 3x and here 3x. So this one and this one are same now, but we have to focus also on this. So we know that there is a property or law, limit x tends to a c of f of x, that will be c, limit x tends to a f of x. That means the constant can be pulled out. So what we can do, 3 can be pulled out before. So limit x tends to 0, sine of 3x divided by 3x. So here this time we have to apply the technique chains of variable, because here we have 3x, here we have 3x. We also need 3x here. So how we can do that? So we need the chains of variable. So let's say we are taking 3x as a single variable theta. Now you can see that here we have theta equals 3x. So since x tends to 0 is given, that means when x is 0, if we input 0 here, so what is the value of theta? Theta is obviously 0. That means when x tends to 0, then theta is also tending to 0. So that means we have to think about in this way. So we are changing the variable. Limit x tends to 0. Instead of x tends to 0, we can write theta tends to 0. Now sine of 3x, that is sine of theta, divided by 3x, that is theta. So this time we can see that here we have theta, here we have theta, here we have theta. So this is actually now 1. So 3 times 1, that is 3. This is a finite value. So limit exists. So chains of variable actually helps us to solve the problem easily. Okay, so we can also take another similar example. So suppose we have a problem, limit x tends to 0, tangent of 7x divided by sine of 3x. So how can we solve this one? We can write this one as limit x tends to 0, tangent of 7x times 1 over sine of 3x. At first, have a look. If we input 0 here, so tan 0, that is 0, sine 0 is 0. It is giving us 0 by 0 form. That means we can apply L'Hopital's rule to solve this. But we are not here to apply L'Hopital's rule. Rather, we will apply algebraic manipulation or chains of variable technique. Okay, so what we can do here, we know that we have formulas limit x tends to 0, sine x divided by x equals 1, limit x tends to 0, x divided by sine x, that is also 1. So what we can do, we can think about these formulas. At first, let us write this one as sine 7x divided by cosine 7x. We can simplify by this way. And we have sine 3x. So now we can write limit x tends to 0, 1 over cosine 7x times sine 7x times 1 over sine 3x. You can understand that I have written in this way just to separate all the terms. So I have written all the terms in product form, but in a different way, so that I can apply these limits. So these formulas can be applied if we have x, x, and x. That means same variable should be in 3 positions. Okay, just now we have seen that technique. So what we can do, we can write by this way, limit x tends to 0, 1 over 7x. Let me give the parenthesis. So our target is to make the same thing, 7x, 7x here. Okay, and here we have sine 3x. This should be 3x. So you can see that x and x can be cancelled, so it is okay now. But at the same time, we have given some extra things, 7. So 7 is given here. Now 7 and 7 can be cancelled. Similarly, here we have used 3. So 3 is written below. So 3 and 3 can be cancelled. That means this term and the previous term are now similar. You can check. So what we can do now, we know that we have product law, that is limit x tends to a, f of x times g of x. Suppose we have also case of x. So what we can do, limit of f of x times limit of g of x times limit of h of x. So limit x tends to a, 1 over cosine of 7x times limit x tends to a, 7 sine 7x divided by 7x times limit x tends to a, where a is 0. Let me write 0. Three x divided by 3 sine of 3x. So you can see that 7 and here 3, these are constant. So we can bring this 7 and 3 before the limit. Let's say we can write here 7 divided by 3. So we don't need to write 7 here and 3 here. Now it is looking more simplified form. So what we can do, we can write 7 over 3. Now limit x tends to 0, 1 over cosine 7x. That is 1 over cosine 7 times 0, that is 0. So we have 1 over cosine 0 times, this will be 1, because we have seen a similar problem here. By using chains of variable, we can write 1 here. I will show how we can write 1. Similarly, this thing will also be 1. So that means we have 7 over 3 times 1 over cosine 0, that is 1, times 1 times 1. So we have actually 7 by 3. So let me show how we can write this and this as 1. So here, let me take limit x tends to 0, sine of 7x divided by 7x. So we have to take the help of chains of variable. Here we have 7x, here we have 7x. At the same time, this one should be 7x. Then we can write 1 as the answer. So what we can do, we can take the help of chains of variable. So we are plugging 7x as theta. Now we considered that 7x equals theta. So if x is 0, so what is the value of theta? That is 0. So that means, now think about this one, x is approaching to 0. So theta will also approach to 0. So that means we can write limit x tends to 0. Now we have theta tends to 0, sine of 7x, that means sine of theta, 7x theta. Now this is 1. So this is how we can write 1 here. Similarly, if we have a look on this one, we have limit x tends to 0, 3x divided by sine 3x. So we can take 3x as theta. So once we have theta for the same problem, so it's wise to take another variable. Let's say t. So we are plugging x as 0. So when x is 0, then t is also 0. So x is approaching to 0, that means t is also approaching to 0. So that means limit x tends to 0, that means we can write now t tends to 0. We have 3x above, that means instead of 3x, we can write t sine 3x, that means sine t. So now we can write 1 because we have t, t, and t. All these are same. So this is how we can write 1 here. So we can see that 7 over 3 is a finite value. That means limit exists. So besides these formulas, we also know that limit x tends to 0, then x divided by x equals 1, and also x divided by 10x with this limit equals 1. So we can also solve this problem by that way. So let me write this one. This time I'm not solving with the technique that I have done here. In the first part, I have simplified 7x to sine 7x and cosine 7x. So here what we can do, limit x tends to 0, tan 7x times 1 over sine 3x. So we want to apply this formula, limit x tends to 0, tan x divided by x is 1, and limit x tends to 0, x divided by sine x equals 1. So here we have limit x tends to 0. What we can do, we can write tan 7x. We need also 7x here. So here we need 3x divided by sine 3x. So x and x can be cancelled. So these things are cancelled. Now we have taken 7. That is the extra part. So this should be multiplied in upper part. 3 is also extra. So 3 is divided. Now 3 and 3 can be cancelled. So we can understand that this term and the previous term are balanced. So what we can do, we can bring 7 and this 3 before the limit. So 7 over 3, x tends to 0. Then 7x divided by 7x times 3x sine 3x. So with the help of product law, what we can do, we can write this one as limit tan 7x divided by 7x times limit x tends to 0, 3x divided by sine 3x. So you can see that here we have 3x, 3x, but this should be also 3x, 7x, 7x. So this one should also be 7x. So we need the help of change of variable now. And you can try, it will be also 1, this will be also 1. So we have 7 over 3. That means it actually doesn't matter which method we are applying, we will always get the same result. Here I have simplified tan 7x to this one, but in the later one I have used this technique. Okay, so say this is method 1 and this is the alternate method. Let's see method 2. So this is how we can solve the limits. 7 over 3 is a finite value, so that means limit exists. So I have discussed here the properties of limits and algebraic manipulation technique and change of variable. So I hope you have understood all these things. So that's all for today. Thank you.